Good day, everyone. Welcome once again to our channel. Okay, I am Tutor Call. So please make sure if this is the first time of you seeing this video, follow us on YouTube, TikTok, and Facebook. Okay. So today, what we are going to be looking at, a topic. One of the topic I is one of the most student issues, but it's actually a very very simple topic: solubility and solution. So the objective of this class is actually very short, but I think what we'll be taking our time in this video is actually the soft questions. Okay, so we're going to look at solutions: saturated, unsaturated, and supersaturated solution. And an easy way to always remember what saturated, unsaturated, and supersaturated solution is. We're going to be looking at solubility and how to solve questions on solubility. So before we proceed, it is very very proper we understand what a mixture is, right? Remember that time when you are dealing with a part of chemistry, any part of chemistry, elements, compound, and mixture, exactly. So what is a mixture? A mixture is just when two or more constituents are physically mixed together, and this is why you always have physical separation of mixture, but you don't have physical separation of compound. So when you look at your textbook, you always see where they tell you, okay, separation of mixture, sieving, and all of this and all of that. Sieving, centrifugation, these are methods in which you separate mixture. Do you know why you can separate them? You can separate mixture because they are physically combined. There is no chemical interaction between them. So imagine you are moving on the road and you are holding beans. You went to buy beans one. So as you are coming back, the beans just fell, the nylon just torn, and the beans fell on the floor. You can easily pick it back into your whatsoever, into your nylon or a new plate, because the beans did not really mix chemically with this, and it's just a physical thing. But then if it is soup and the soup pour on the floor, will you be able to pick it? You don't leave it, go unless it's just a meat you pick out of it. Exactly. That's just a realistic explanation on how you can differentiate between separation of mixture and rest. So when we talk about solution, actually, if you are dealing with solubility, there is no how you will not understand solution. And if you are dealing with solubility, there is no how we will not talk about saturated, unsaturated, and supersaturated. So what is a solution? Solution is a kind of mixture, but it is homogeneous. It is very important we understand this. Solution is homogeneous. What does homogeneous mean? Homogeneous, another word can use for homogeneous is uniform. It is uniform. It is not just homogeneous, it is also uniform. You get that? So an homogeneous mixture, that's what a solution is. So solution is actually an homogeneous mixture of two constituents, solute and solvent. So solution, should I write it here? Yeah. So solution is equal to solute plus solvent. A very necessary factor you should take note of. Solution is solute plus solvent. What is solute? The substance that is being dissolved. What is solvent? The substance dissolving the solute. So solute can either be gas, it can be solid, and it can be liquid. Solvent also can be gas, solid, and liquid, but most time solvent is usually a liquid most times. Okay, so anytime we talk about solvent in this respect, most time I'm referring to what? By referring to a liquid. But solute can be a solid, gas, and liquid. But most cases too, when we're dealing with solutes, we're referring to solid. So what is a solution? A solution is an homogeneous mixture of solute and solvent. Homogeneous mixture of solute and solvent. So if I take a solute and I take a solvent together, it will give me an homogeneous mixture. That's what a solution is. Sometimes it could be heterogeneous, but most times it is homogeneous. So, for example, in this case we are dealing with now, if I add salt and water, it will give me salt solution. Salt solution. So this is what we'll talk about a solution. The salt solution most times is uniform. When we say homogeneous, what does it mean? Homogeneous means it is in one phase. Heterogeneous means it is in different phase. So a good example is when you mix oil and water. What do you see? You see two mixtures now. You see something like the oil at the top of the water, right? Exactly. That's two phase because this oil is less dense. It superimposes the water. So anytime you talk about heterogeneous mixture, we're talking about mixture in two different phases. Okay. Then when we talk about homogeneous mixture, it means just one phase. There's no separation. You're not seeing anything like up and down there. Exactly what we're dealing with it. So having understand that what a solution is, it is very, very important to have about saturated, unsaturated, and supersaturated solution. This particular thing actually confuses a lot of students. It confuses them. What is a saturated solution? Well, let me start with unsaturated. Unsaturated solution is actually a solution that can still dissolve much more solute. That's unsaturated. A solution that can dissolve much more, that is, it has the ability to dissolve more solute, is what we call unsaturated. How about saturated? Saturated is the one that does not have the ability to dissolve more solute at a particular time. Please, you have to understand that the solubility of solute in solution is actually dependent on temperature. Okay, for solid now, as the temperature increases, the solubility also increases. But for gases, these are potential, especially those depend on post-seminar and jam. These are potential questions they can ask you. The solubility of solid increases with temperature. As you are increasing the temperature, the solid, they will keep dissolving. Like the solubility of the solid inside a solvent, a solvent to form a solution, it keeps increasing as you are increasing the temperature. So temperature is a condition or is an aid for increasing solubility of solid. There are some solid that has an exception, like calcium hydroxide, calcium sulfate. These two solid is an exception that is given in test. So if they ask you, these are how they can ask you in jam or question. You can say, which of the following solid, its solubility decreases with an increase in temperature. If you see calcium hydroxide or calcium sulfate there, you can pick those. Those are the notable examples jam and wide or question usually use. But generally, the solubility of solid increases as the temperature increases, but the solubility of gases decreases as the temperature increases. Very important to take note of this. What do I mean by that? If I increase the temperature from 20 degrees Celsius to 30 to 40 to 50 to 60, as I'm increasing it, gases solubility will be decreasing. What helps gas to be soluble in solvent most time is pressure, and it was actually derived from a law known as Henry's law. Those of you who have gone for like those 100 level students, you know this Henry's law. So it's actually a law that actually tells us how the solubility of gases increases with temperature. Very important. So solubility of gases increases with pressure but decreases with temperature. So I only quickly said that so that we can understand that temperature is a key factor in determining the solubility of solid or determining the solubility of substances in solution, like saturated, unsaturated, and supersaturated. So like I said earlier, at a given temperature, a solution that can still dissolve much more solute is what we call unsaturated. But at a given temperature, a solution that can't dissolve much more solute, it cannot dissolve. It has accommodated as much solute it can receive at a particular temperature. Sometimes in the presence of undissolved particles or undissolved solute, that solution is what we call saturated. Then the one where it has exceeded its maximum, it has accommodated or accumulated much more solute, more than its maximum, is what we call supersaturated. I know this definition I just gave you now is actually looking as if you see looking one kind in your head, but then let me use an illustration for you. So let's take for example that at 80 degrees Celsius, are you following me? Let's say at 80 degrees Celsius, a particular solution can accommodate 100 grams of solvent. Let's say at 80 degrees Celsius, 30 grams of salt, which is a solute, can dissolve. 30 grams of salt can dissolve in 100 grams of water. I'm giving you an illustration of that. This is what is happening. This is it. Once it is 80 degrees Celsius, the maximum amount of salt that can stay in this 100 grams of water is 30 grams. Are you with me? But then at this 80 degrees Celsius, this 100 grams of water only have 20 grams of salt in it. This solution at this stage is called unsaturated. Why? Because it has room for 10 more grams of salt. Do you understand? So an unsaturated solution is one that can still accommodate, that can still receive much more solute
after it has, much more solid after it has the ability to still receive more solid at that particular temperature. But if at this 80 degrees Celsius, this 100 gram of water contains 30 gram of salt, it is now what we call saturated. So if from this statement at 80 degrees Celsius 30 gram of salt can dissolve in 100 gram of water, then you come at 80 degrees Celsius, you now brought 36 gram at 80 degrees Celsius. What you will notice is that 30 gram will dissolve, then 6 gram will be left undissolved. This is where the definition of saturated solution demonstrated that it is at a particular temperature, a solution that can accommodate, that has received as much solid it's supposed to receive in the presence of undissolved solute. So if you bring 36 gram, the normal capacity or capability of that saturated solution is 30 gram. We are bringing 36 gram. So the 30 gram will dissolve, and the 6 gram will be left undissolved. The only way you can accommodate this other 6 gram, is by either increasing the temperature, because I said as you increase temperature, solubility of solid will increases. So if you increase the temperature to 100 gram, then possibly the 6 gram will dissolve. Or by increasing the solvent, the amount of the solvent, by either increasing this 100 gram to 120 gram or 150 gram. That's the only way this 6 gram can. But as long as this statement is there that okay, this is it. So in a simple term, saturated solution means a solution that has received its maximum capacity of solute. Are you following now? Exactly. You get what I'm saying now? Exactly. So when it is saturated, it means it has received its maximum capacity. That's the highest it can receive. Any other solute added to it will result to being undissolved. Then when we now say supersaturated is now that case when I receive much more than it can actually absorb. So let's say now I want to give you 2 illustrations, because sometimes you'll be wondering why is it that. Let me just give you this illustration. So let's say a particular solvent at 80 degrees Celsius. It has 30 gram. Before I said that, let me now give you this. So a supersaturated solution is one that has much more than it can actually accommodate. So at 80 degrees Celsius, it can have 30 gram of salt. 30 gram of salt can dissolve in this is the statement. But then this particular 100 gram is having over 30 gram. It's having like 6 gram. Now, somebody will be confused how. You'll be like, oh, you said earlier that once a solution is like the saturation point of this 100 gram of water, the saturation point of it is that it has that at 80 degrees Celsius, it's saturated when 30 gram of salt is present in it. But because when I was coming up, I was actually reasoning this thing. I don't know if as a student, when I was writing down those years, I was actually reasoning this. How is it possible if you say that okay, at saturated point, that it has received its maximum capacity? Then how then do we now have super saturation? Because it's not supposed to be possible. We say that if it is saturated, it cannot receive much more solid again. That's where it will stop. The solid that is coming will remain undissolved. But then how is it now possible for we to have super saturation where it has received more than its capacity? Super saturation means it is receiving it is able to dissolve about 40 gram, 50 gram, that is above this 30 gram. Then how is that possible? This is how it's possible. Let me show you something now. So if we say at 80 degrees Celsius, 30 gram of salt can dissolve in 100 gram of water. This same water, because as I'm reducing the temperature, what will happen to the solubility? It will also reduce because temperature works with solubility. So let's now say at 20 degrees Celsius, this particular water, because if we are reducing the temperature, it means the amount it will receive will also reduce. At 20 degrees Celsius, this particular water can receive just 15 gram of salt. Are you with me? This particular can receive just 15 gram of salt at 20 degrees Celsius. So which means that at 20 degrees Celsius, the saturation point is 15 gram. At 80 degrees Celsius, the saturation point is 30 gram. And this will happen if the maximum capacity it can receive at 80 degrees Celsius is 30 gram. Are you with me? Then I now started reducing the temperature down small to 60. If you begin to cool this solution little by little, if you do it well without shaking it, without scrubbing it, at least, okay, let's take it a bit so that you will not be confused. This is what I'm trying to explain to you, how we get super saturated solution. A super saturated solution is gotten when you cool a saturated solution from the saturation point down. When you cool it, that's where you get a super saturated solution. So if I begin to cool this particular solution at 80 degrees, it has received its maximum 30 grams. If I begin to cool it gently without shaking it, without shaking it, you will notice that at 20 degrees Celsius, the amount of salt we are going to have in that water, that 100 grams, will still remain 30. It will not be 50. Are you know, normally at 20 degrees Celsius, it's supposed to take, the maximum it can take is 15 grams. That's the normal way. But if you cool it well without shaking it, if you cool it as you cool it and you shake it, some of the solute that has been dissolved, they will crystallize out. If you shake it, if you do it anyhow, they will crystallize out of the solution, because normally it's not supposed to take more than 50 grams. They will crystallize out if you shake it. But if you do it gently without shaking it, even at this 20 degrees Celsius, that its maximum capacity is 15 grams, it will be holding 30 grams. So at that point, we say this, at that 20 degrees Celsius that is holding 30 grams, we say the solution is super saturated because it has received much more than it can actually dissolve, which was 15 grams. But then it's holding 30 grams instead of 15 grams because we cool it very well without shaking it. But if at that super saturated solution, at that point, it is unstable. At that point, because it's taking more than it can actually receive. If you shake it or do any disturbance or you scrape it, it will crystallize out. This is where we get crystallization of salt. Are you following that? Exactly. So that's the difference between saturation, unsaturation, and supersaturation. In this, you can easily get it. Saturation is the point where it has received its maximum. Any other thing coming will be left undissolved. Unsaturation is when it can still receive, while supersaturation is when it has excess of it. So supersaturation does not mean that there is undissolved. No, don't get it wrong. The most students used to think that when it is supersaturated, it has a lot of undissolved particles. That's how I used to think too, but no, that's not it. Because supersaturation is mostly gotten from saturation, just cooling it gently, then becomes supersaturation, just as I have explained here. Are you following now? Good. So having understand that, now let's now talk about solubility. So what is solubility? Solubility is just when a solute is dissolved in a solvent or in a solution. There are different ways it can be calculated. Actually, where our attention should dwell today or in this video is in the calculation aspect. So solubility is the amount of mass of solute in gram dissolved in 1 dm cube of solvent, or the amount of solute in moles dissolved in 1 dm cube of solvent, or amount of solid or solute in mass, that in gram, dissolved in 100 gram of water. So solubility is any of these things. So solubility can be calculated in gram per dm cube, can be calculated in moles per dm cube. It can also be calculated gram per 100 gram of solvent. Now, there's actually just one formula you can use to solve question on solubility, but there are some technical cases where you have some kind of state or some kind of case where the thing looks kind of ambiguous, but I'm still going to explain. I'm going to do some examples to understand what I'm trying to say. So if this is the general formula for solving question on solubility, the general formula, so you simply say solubility, the general formula equals to mass of solute over mass of solvent. Don't forget this formula, it will help you very in your exam, times 100. That's just the general formula. So any answer you get from here, if it is 10, you get, that's how it be 10 gram per 100 gram of solvent. This is how you write it. If your final answer 10 gram per 100 gram, this is how you write your final answer. What does this mean? It means that we have 10 gram of solute dissolving 100 gram of the solvent. Are you following that? This is how you just do this is how you solve it. But there are some cases where the question will not give you the mass of the solvent, rather they will give you mass of solution. Please, this is the point where you start getting me well, because I don't like to get misunderstanding what I'm saying. Okay, so you can see from this formula here, you will notice that what we actually need is mass of solvent. Most times they'll say find the mass of solute. So what we actually need most times is the mass of solvent. But some questions will not give you the mass of solvent. They will rather give you the mass of solute. And it will be difficult in getting the mass of the solvent. They will rather give you the mass of solution. Yes, they will rather give you the mass of solution. And in this case, we are not using solution here. So it will be difficult in getting your mass of solution. So in that aspect, when they give, there's another way we are going to solve it. When we see an example, I'm going to explain them. So let's look at some example anyways. So this is solubility, mass of solute over mass of solvent times 100 gram plus times 100, as easy as that. Mass of solute, we already know what solute is. Remember, solution is what? Solute plus solvent. So if they give me 30 grams of solute, 100 grams of solvent, what will be my mass of solution? 30 plus 100, that's what? 130 grams. So don't forget it. Sometimes they can give you the mass of solution to be 50, mass of solvent to be 30. What is the mass of solute? You just subtract. It's a simple mathematics. So we want to solve question now. We already understand what solution is, saturated and this. But before I even proceed to solving question, there are some theoretical questions they can ask you. You know, water now. Water is actually is known as universal solvent. Water is known as what? A universal solvent. Why? It is known as a universal solvent because it has the ability of dissolving many solids. That's a jam question. I've seen it. Water is known as a universal solvent because it has the ability of dissolving many solids. It can dissolve many. That's why we call it water. That's how we call it universal solvent. Any solid that is dissolved in water is called an aqueous solid. Don't forget, these are potential questions. Aqueous. When you see the thing that says aqueous solution of sodium hydroxide, what is it that sodium hydroxide dissolved in water? Aqueous solution of NaCl, that's sodium chloride. It means that sodium chloride dissolved in water. Anytime you hear the word aqueous like this, it means that substance was dissolved in water. Now there are also some important questions you can see. They can be asking you. Please take note of this. When you have a coffee stain, these are jam and procedure questions. I think this coffee stain became a unique pass question. Coffee stain, which solution do you use to use borax solution? Borax solution, that is the compound known as sodium bromate, something, but just call it borax solution. So this solution is actually used to remove coffee stain. Paint stain, I think that's turpentine. Yeah, turpentine is used to remove paint stain. Anything like oil stain, you use kerosene, ammonia, or use petrol. Take note of this. Borax solution for coffee stain, coffee or tea stain. So they can ask you a question that coffee or tea stain can be removed by which of the following solution? A, borax solution. B, turpentine. C, kerosene. D, ammonia. That's a question. That's a jam question or question. You can answer this borax solution in universe pass question. So borax solution is a solution that is used to remove coffee or tea stain. Anything that is oil stain, fat stain due to fat, you can use either petrol, ammonia, or use kerosene. There was a time when I was still small. I remember my mom coming back buying some wrapper. There's this they usually place on the wrapper that a sign, or would I call it a symbol? They just come it there, and if you want to remove it, it's difficult. It's kerosene she used to remove it. So this is what I'm talking about. These are some of the uses of solution, and it comes out in the exam. Sometimes they will not just test your knowledge in all this calculation. Sometimes your knowledge will be tested on what? On all this simple formula. Very, very important. Take note. I'm begging about that. So it came to my mind as I'm saying it. So we have understood that uses of solution. So now let's solve some questions. Let's look at the first set of questions. Okay, these are both jam, like, or extremely likely questions that you can find. Look at them. They come back. Look at the first question. We'll start with the first. It said at 25 degrees Celsius, 23 grams of potassium chloride dissolve in 100 centimeter cube of water to give a saturated solution. What is the solubility of the salt in gram per dm cube, mole per dm cube? What is the solubility of the salt in gram per dm cube and in mole per dm cube? Now, from that statement alone, you should be able to understand that when they say find solubility of the salt in gram per dm cube, it simply means gram is the mass, dm cube is the solvent. So solubility, first question, solubility in gram per dm cube is simply mass in gram over mass of solvent, mass of solute in gram over mass of solvent in dm cube. But if you look at the question, our solvent was given in 100 centimeter cube, so we have to convert that to dm cube. How many? What's the relationship between dm cube and centimeter cube? Remember that 1 dm cube, 1 decimeter cube is 1000 centimeter cube. If I'm to change this 100 centimeter cube to dm cube, I have to divide by 1000. So this our 100 will be 100 centimeter cube over 1000 centimeter cube. I'll get my answer in 0.1 dm cube. So with this now, I'll be able to convert my centimeter cube to. So first thing I did was I converted my solvent, mass of solvents, in centimeter cube to dm cube. that's what the equation tells us to get mass in gram per dm. My solute is already in gram. So just impute it to have 23 over 0.1. That's 230 gram per dm. This stuff is not difficult. Do you understand? It's not difficult at all. So the second one is finding in mole per dm. Solubility in mole per dm is simply solubility in gram per dm over molar mass. We have KCl there. So find the molar mass of KCl, molar mm. Molar mass of KCl is, you know how to do that, right? The mass of potassium is 39 plus mass of chloride is 35.5. That'll give you 74.5, right? So now solve. The solubility in mole per dm, solubility, I'll just write SOL in mole per dm cube. Simply the solubility in gram per dm, over molar mass. So that be solubility in gram per dm cube over molar mass mm. Are you following me now? So solubility in gram per dm cube we already got here is 230. The molar mass we already got here is 77.5. Then press your calculator. So you press your calculator. 230 divided by 74.5 as 3.09. So the between mole per dm cube is 3.09 mole per dm cube. Are you following me? That's how we got the answer to that. It's not difficult. Let's check number 2 question. For number 2, it says 30 grams of sodium chloride. So mass of salt or mass of solute. Mass of solute 30. Saturate 15 grams of water. Mass of solvent 15 grams. Right? Calculate the solubility of anything at that temperature in gram per 100 grams of solvent. I gave us the formula, right? So solubility mass of solute over mass of solvent times 100. Is that not it? That's 30 over 15 times 100. Let's go. Yeah, good. That's 200 grams per 100 grams of solvent. So at this particular temperature, we have 200 grams of solute dissolving in 100 grams of solvent. So this is how to solve. This is just the calculation. Solubility is equal to mass of solute over mass of solvent times 100. As long as they gave you solvent and solute, you just use this formula as easy as that. But now look at this question 3. Can you try it out? Pause the video and try it out. I know some people will be like, oh, imagine seeing this question in your wife. This question mostly comes in theoretical aspect of why. Sometimes it comes out in jam. Yes, it comes out in jam. I've seen one long question like this in jam before. And so students will be confused, don't know what to do. It's still the same thing. Let's just see. Let's go. So let's see this question now. An evaporating dish weighs 31.18 grams. An evaporating dish is a dish where the solution is placed in, then what they call it evaporating dish because they want to evaporate water out of the salt. They want to remove water from the salt. So an evaporating dish weighs 31.18 grams. Weight of dish 31.18 grams. That's the first thing. The second thing here now, when filled with a saturated, emphasis on the word solution. You see, when filled with a saturated solution of CuSO4, copper sulfate, at 32 degrees Celsius, it weighs 48.39 grams. So now weight of dish and solution is what? 48.39 grams. Did you see that? The weight of the dish and the weight of the solution is 48.39. So what will be the weight of solution? Weight of solution. I just abbreviated the SOLN. Solution. Weight of solution will be what? Just do your small mathematics. If only the dish is 31.18, dish and solution is 48.39. Only solution would what? Good. 48.39 minus 31.18. That will give us 48.39 minus 31.18. 17.21. So that's 17.21 gram. 17.21 gram. Now let's move on. The now further said, after evaporation to dryness, the evaporating dish and the residue is what's remaining. That's obviously the salt, because remember the evaporating dish is used for removing water from a solution. The solution contains the solute and the solvent. So if the solvent has been removed, what will be left with the solute? That's the solvent. That's the solute. That's the salt. So if the evaporated dish and the residue weighs 33.98 grams, so weight of dish plus solute, I'll just call it solute, not residue, because that is the same thing, is 33.98. Now what will be the weight of the solute now? Because this one, many students will assume this weight here to be the weight of the solution. Many students will assume this weight here to be the weight of the solution. It's wrong. They said it now. Read the question. They said, when filled with a saturated solution, it weighs it gets. Your ability to be able to understand and explain question is what will help you solve it. You can know the formula and still fail a question. Yes, you can know the formula and still fail a question. So your ability to be able to understand and solve it is what helps you actually. Now, so the weight of solute will now be what? The same thing. 33.98 minus the weight of the dish. 31.18. Okay, so our answer will be what? 33.98 minus 31.18. 2.8. So weight of solute is what? 2.8 grams. Now let's find our solubility. We have to find solubility though. So what solubility is equal to mass of solute over mass of solvent. That's 100. But then, what is the mass of solvent? Is it this? No. What's this weight of solvent? This mass is the mass of solution. We're not using mass of solution. So we'll find the mass of solvent. So if you refer back to what I told you earlier part of this class, I said solution is what? Solute plus solvent. So I have solute to be 2.8. I have solution to be 17.2 now. What will be my mass of solvent? Good, the minus. So mass of solute is what? Mass of solute is 2.8. Mass of solvent will be 17.21 minus 2.8 times 100. So solving this with our calculator, 17.21 first, 17.21 minus 2.8. That gives us 14.41. That will be 2.8 over 14.41 times 1. You can just press your calculator from here and it will give you your answer. So 2.8 divided by 14.41 times 100. 19.43. The answer is 19.43 gram per 100 gram of solvent. So this is how you solve it. You can see that this long question is actually not have the ability to explain it. Is what we can if you be able to solve question. So now, having understood this, now let's check other questions. Like, remember I said this formula is the general formula, but though there are some questions that they will not give you solvent, they will give you solute, and it will be difficult in getting the mass of solvent from it because they want you to find the mass of solute. They will give you the mass of solution, and without giving you mass of solvent. So we know without solvent we cannot use this formula. So there's another way we have to solve it. So that's the next part we want to check now. So let's solve the next set of questions. So let's look at the next set of questions. Look at this question. It says at 15 degrees Celsius, the solubility of sodium chloride is 42 gram per 100 gram of solvent. Calculate the mass of sodium chloride in 10 gram of a saturated solution at the same temperature. This question is actually very, 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 very easy because number one thing I want to I want you to understand is that, remember the process we solved in the last one. I gave you a formula, and I said it earlier that there are some questions like this, obviously, that formula cannot work for, because that formula actually talks about mass of solvent and mass of solute. But in this case, they don't give us mass of solvent and mass of solute. So there's a different process we are going to use in solving this question, a different process, a different approach. And what is the approach? So because we were given mass of solution, now we could have used that formula if like they gave us the mass of solvent. Look at, this is the formula we use for solution. Solution is equal to solute plus solvent. Is that not what we said? Solution is equal to solute plus solvent. So we have our mass, our solute initially, but we don't have our solvent. So we are looking for a solute. We are looking for our solute. We have our solution, 10 gram, and we are looking for a solute. For we to get solute, we also need solvent. So they did not give us solvent, they did not give us solute. So that's how that formula cannot work. So there's a different approach we have to use in this case here. So what is the approach? First, we will say at 15 degrees Celsius, at this particular temperature, the mass of solution is 42 plus 100. That's 142 gram. Why did I say this? I'm using this because in order for me to get look at the question. At 15 degrees Celsius, the solubility of sodium chloride is 42 gram per 100 gram of solvent. Calculate the mass of sodium chloride in 10 gram of a saturated solution. Now they told us that at 15 degrees Celsius, 42 gram of sodium chloride can dissolve in 100 gram of solvent. Okay, but then they want us to tell them how much mass of the solute, that sodium chloride, can dissolve in this 10 gram of solution, not 10 gram of solvent. So for me to get the amount of solute that will dissolve in 10 gram of solvent, I will have to know the initial amount of the solution first, which is what I have done here. Having known this now, then I will proceed by saying, okay, 142 gram of solution contains 42 gram of solute. Is that not it? Then 10 gram of solution will contain how many mass of solute? X, because we don't know it yet. That's what we're looking for. So if we get to this place, we just cross multiply. Now the issue many students have is that many students, this is what they would do. Since they give them 100 gram of solvent, they would rather say 100 gram of solvent give us 42 gram of solute. Then 10 gram of solution give us X gram of solute. But that's wrong. Do you know why? Imagine saying 100 gram of solvent give us 42 gram of solute, then 10 gram of solution. Is wrong, because how can you compare solute and solvent? How can you use solvent and solution at the same distance? It's not making sense. Just like you using meter as length, then later on in that same solution you're not using centimeter. In physics, you see that it's not making sense exactly. So because they did not give me mass of solvent, that was why I had to, because in this case now they did not mention solution to me, they gave me solvent. So I had to use that. Since they am to look for the mass of solute inside this solution, I will have to use solution in my first instance. So I have to add 42 gram of solute plus 100 gram of solvent. That's what I did here to get this 142. So from then, if I cross multiply, which I want to do next, let me rub off this one. So cross multiply will have 142 gram times x is equal to 42 times 10. We divide both sides by 142. We have x equals 420 over 142. If you press your calculator, you do 2.96 grams. So that's the mass. That's very, very easy. It's not difficult. So let's look at the next question. Now look at the next question. Now look at it very well. You see, it says the solubility of copper sulfate at 100 degrees Celsius is 50 gram in 100 gram of water, and at 20 degrees Celsius is 5 gram. If 120 gram of saturated solution at 100 degrees Celsius is cooled to 20 degrees Celsius, calculate the mass of copper sulfate deposited. This is very, very easy. Very, very easy. Now this is it. They actually have the solution at 100 degrees Celsius. Then at 20 degrees Celsius, they have that same solution. Man, this is what happened. At that 100 degrees Celsius, it was saturated. They now cooled it to 20 degrees Celsius. What they want us to find now is that we should find how much of the mass we deposit. Maybe during the process they shake it. Remember I said the only way when we cool and salt crystallize out is when we have shake it. I said it earlier, right? So now this is very, very easy. Now this is what we'll do. At 100 degrees Celsius, right? What is the mass of the solution? We have it 50 gram in 100 gram of water. So mass of solution is 50 plus 100 equals 150 gram. Then at 20 degrees Celsius, are you seeing it now? So at 20 degrees Celsius, what will be the mass of solution? Mass of solution is equal to, look at it, 5 gram in 100. That will be 5 plus 100 equals 105 gram. So then, the question says they cool it from 100 degrees Celsius to 20 degrees Celsius. The solution will add 120 gram. What will be the mass? So we now go. After cooling, we have, if 120 gram of saturated solution at 100 degrees Celsius is cooled to 20 degrees Celsius, calculate the mass of copper sulfate deposited. So after cooling, we have 150 gram minus 105 gram. Now somebody be wondering, why am I subtracting? Because if you are cooling it, remember it's a reality. Something. As you are cooling it, some mass will be coming out. They'll be crystallizing out of it. So the mass that will actually crystallize out of it in terms of the solution, and the solutes that will crystallize is what we are subtracting. 150 minus 105 will give us 45 gram. Okay, now this is it. If we want to know how much of the mass that will crystallize out in 120 gram of solution, we'll simply say, okay, since 100 degrees Celsius is the highest step, that's where we have the highest saturation point, we are going to make use of the 100 degrees Celsius. So we'll say, okay, for after cooling, we want to get the mass of solid that will crystallize out. So we'll simply say 150 gram of solution contains or crystallize 45 gram of solute. Now the question is, why did I not use 20 degrees? Why did I not use the mass of solution at 20 degrees? Why am I using the mass of solution at 150 gram? Why am I using the mass at 100 degrees? I'm using the mass at 100 degrees because the higher the temperature, the higher the saturation point. I can't use the low to find it. I have to use the high one. Yes, it's the high one you have to use. The one at 100 degrees Celsius. If it is between 50 and 10, use the one at 50 degrees Celsius. Are you following me now? So let's go. 150 gram, that's at the higher 10, 150 gram of solution. It was from this one, it actually, hope you know that it was from this one the crystallization actually came out from. This 45 gram actually came out from this 150 gram, not even at the 20 degrees Celsius. Because as you begin to cool it from that 100 degrees Celsius downward, it was out of 150, 10 left, 20 left, 30 left, 40, until it became 105. I think it's making sense. It keeps decreasing until it became 105. So I can't use the 105. The 105 is the one remaining. Are you with me? So we are dealing with the one that has left. Okay, that's I'm using this one. So 150 gram of solution contains 45 gram of solution. 120 gram of solution will now contain what? X. Because this was they want us to. They said, look at the question. The question said, if 120 gram of saturated solution at 100 degrees is cooled. So when they now this is it. Initially we have 150 gram at 100 degrees Celsius. Then when this 150 gram was cooled down to 20 degrees Celsius, when it was cooled, very very at 100 degrees Celsius, mass of solution is 150. At 20 degrees Celsius, mass of solution is 105. So when it was cooled from 100 degrees Celsius to 20 degrees Celsius, the mass that crystallized as was what? 45 gram. Now, if we now cool 120 gram of this solution from 100 degrees Celsius to 20 degrees Celsius, what will be the mass that will crystallize out? That's what we are looking for. So at 150 gram of solution, that's 100 degrees Celsius, 45 gram of solute was crystallized. Then if 120 gram of solution is what we are using now, what will be the mass that will crystallize out? X. We don't know it, we just cross multiply. So we have 150 times X is equal to 120 is 45 divide both sides by 150. Press OK. So we have x equals 120 times 45 divided by 150. That's 36. So the answer is 36 grams. That's what to crystallize that. So guys, that's actually all about solution and solubility. Your question will literally come from all these aspects. If you know you enjoyed this video and you watch this video to this point, first time we say thank you for staying and watching. So please do well to share, like, subscribe to our YouTube channel because we're doing more of these things like that. Okay, and don't forget that if you are someone preparing for exam, you need a tutorial where you'll be taught, you'll be put through, you'll take online mock exam, you'll test yourself, test your speed, you get access to free textbook and get access to video classes like this that we make especially for our students on all topics at all. Then do well to reach out to us on this number 07036 59 30 57. So I am Tutor Black. Or just message me and then I saw your video somewhere and I decided to message just and I will reply you, then add it. Then we'll first put it through and then continue from there. So I've come to the end of this video and if you like it. If you are watching from TikTok, I don't know if you will get the full video clip on TikTok, but make sure you check on YouTube. All you have to do is search Tutor Black and you will find it. So this is it, Tutor Black. Have a nice day, guys.